metaphors matter because it does shape the way that we think about the problem and therefore approach the problem, what we consider to be a win or not. But I think the better metaphor is we need to compost late-stage capitalism.
Welcome to the Regeneration Will Be Funded. I'm your host, Matthew Monahan, and in this series, we're having conversations about regenerative finance, technology, and our living planet. How can we build an economy that's in service to life? Brought to you by Ma Earth. You can find all of our conversations at maearth.com. Thanks for joining us. Today's conversation is with Tom Chi, founder and managing partner of @One Ventures. @One Ventures aims to make humanity a net positive to nature. In this discussion, we go through Tom's framework of the 3 epochs of ecological technologies, the opportunities within each of them, financial considerations, and some example companies. We also talk about the nature of venture financing and capitalism. I did my best to keep up with Tom, which I admit was a challenge, but I hope you find value from this conversation. Let's dive right in with the one and only Tom Chi. Welcome. Today we're here with Tom Chi. Tom is the founder and managing partner at @One Ventures. Thanks, Tom.
Yeah, great to be here.
And how's your climate week going?
It's chaotic and confusing, so I think as planned. Yeah.
Any observations so far from New York Climate Week?
It's like 100 different organizations all like choose to do 3 or 4 events in the week, and they're all like, come to my event. And it's like, oh, this is the worst possible thing for an introvert. So, hey, it's a miserable week on that front, but have been able to spend time with folks that I like. So that part's good.
Great.
Yeah.
And maybe to start off, can you frame what is @One Ventures?
Oh, sure. So @One Ventures, the purpose of our firm is to help humanity become a net positive to nature. And it's called @One Ventures because the purpose is to be at one with ourselves, nature, and the universe. What we do is we do early stage deep tech for climate and environment. So typically entering seed and A kind of round, and then using venture to go disrupt, which is what venture is generally trying to do, but instead of just any type of disruption, right? Because Facebook disrupted the newspaper industry, but maybe we got more negatives than positive on that. But like instead of just like any type of disruption, which by the way, venture likes because you make a lot more money if you disrupt a thing. Even if you damaged it, like sometimes you can make a bunch of money disrupting it. Instead of doing it kind of willy-nilly like that, we aim to go disrupt the industries that are doing the most damage to nature. So for us, nature has got 4 subcomponents: air, water, soil, biodiversity. So all the things in emissions fall under air. So we, of course, touch everything to do with the major greenhouse gases. But we also care about water, soil, biodiversity. And within each of those 4 categories, we stack rank the industries that are doing the most damage. And those are the ones that we aim to disrupt. So it's a very systematic approach to kind of, it's kind of our Pareto approach to doing like the most positive disruption, by massively reducing the environmental footprint of the industries that are doing most damage to nature.
Mm. And you gave a really interesting talk at the 2022 general meeting for @One Ventures, which I wanted to somewhat reference and use as a frame for this conversation, where you described the different epochs of ecological technologies. Maybe to start, can you help unpack that frame and we can walk through each of them?
Yeah, there's 3 epochs. The first one is material productivity. The second one is moving toward the optimization of metabolic flows as opposed to just dealing with the noun and materials. And I'll get into more detail on this. And then the third one is called the maximization of diverse nutrient flows, which is also a synonym for the algorithm for all of life in the universe, right? That's basically what life in the universe is trying to achieve. And there's a bunch of thinking behind this. I'm just giving the whirlwind overview. And then there's Epoch 0, which is before you get into any type of ecological technology, which is the world today. fully extractive, could care less about the environment. So we're kind of moving between Epoch 0 to 1 right now. And there's a lot of opportunities on the investment side in Epoch 1. And then there's some kind of around the corner on 2 and 3. And it's really in Epochs 2 and 3 where you start to move toward like an economy, a civilization that is fully compatible with nature. But you're going to pass through 1 on the way there.
Right. And here in the 0 state, you framed it as we have an economy that is, our current economy is incompatible with the planet or with life on the planet.
Because the general gist of anything, whenever you're trying to get economic advantage, is you want to use a smaller amount of money to be able to go unleash a larger amount of money. So like in that way, kind of a broad definition of the word leverage. There's, of course, more financial services like sensibility of leverage, but imagine the broader sense of it, though this is also financial leverage. And, in Epoch 0, in the extractive economy, then what more leverage on the thing looks like is, I have a forest, and if I can cut down the forest in half the time, using equipment that cost half as much, then, productivity has been gained because my CapEx went down, the time it took, maybe my OpEx went down, the time it took to go extract this resource, clear cut this forest went down, Now, that's obviously incompatible with nature, right? And actually a thing that's really worth reflecting on, especially as we try to convince ourselves that we live in like this virtual economy and everything's going to be bits and whatever, is that just none of that is true. Everything in the economy was either mined or grown. There's no exceptions. Like if you just look around the room around you, you have that lampshade, that's like probably cotton that was grown, right? Like metal, this was mined, right? And we can basically go around literally everything physical in the economy, either mined or grown. Even the digital stuff is, of course, hosted on physical things, right? So you basically cannot get away from the fact that every aspect of the economy is mined or grown, and it means it directly comes from nature. There's basically no intermediaries. Like you can pretend you live in a virtualized world. You can pretend that the footprint of this or that is like minuscule. But we're now in the spot where server capacity plus crypto mining or whatever is now an appreciable part of the greenhouse gas mix. It's just as physical as anything else. So number one, we shouldn't fool ourselves that we're moving into a fully virtual economy and we're dematerialized at a level that we're not. I'm not saying...
Are we similarly fooling ourselves when we talk about 100% clean energy and the green economy in terms of, we're going to just use solar panels and windmills and EVs to solve this problem?
Well, there's a lot of nuances on that. So there's a lot of things that are just concretely true. So when you, like an electric motor compared to an internal combustion engine actually is just directly more efficient.
Right.
And people are like, oh no, but if your electricity is powered by coal-fired power plant, it's no better. It's like, no, that's actually not true, right? Just the direct efficiency of the electric motor is like twice as good as the internal combustion engine. And you can tell because it doesn't waste a lot of its energy and heat. So if you like drive your electric car for 100 miles and put your hand on the hood, it's not even a little warm. I mean, if the sun is shining, it'll be warm from the sun. But there's not a bunch of like waste heat coming out of the hood. But if you can cook an egg on a lot of engine blocks that are internal combustion engine.
Right.
And that's a lot of the energy in the gasoline basically becoming thermal waste heat. So no, just directly. So there's a number of things that are just concretely true where it is advantageous to go electrify or make some of these changes. So I wouldn't say like we're fooling ourselves like a binary type thing, but there's a lot of nuances as well, right? Like the materials to make a battery electric vehicle, the lithium, the manganese, nickel, cobalt, all these kinds of things. These are things that do not have infinite availability. And there's a group at Argonne National Labs, and they were one of the teams that spent a lot of time like creating the modern lithium-ion battery. And they basically estimated that we run out of economically extractable lithium by the time we do about 45% of the cars. So when you think about all the other things that we wanted to go do with lithium batteries, then you run into a little bit of a jam on that. Now, this is not to say, like, very clear, there's enough lithium on the planet, right? In fact, there's an insane amount of lithium dissolved in the oceans. but the amount of energy that is required to be able to go extract that starts to become, so highly prohibitive. So this is the reason that a lot of the lithium that we do mine was like an inland sea that dried up over the course of millions of years. Because basically the sunlight could dry it up, the different forces could dry it up over an extended period of time. And now all that's left over is these concentrated mineral deposits, like in the ABC region in South America, or the Salton Sea, in North America, and on, right? So, if we needed to go apply that energy in a fraction of the time, then, power is dEdt. It's the amount of energy that is applied, the change in energy that's applied divided by the amount of time. So if you need to get that lithium out in a short amount of time, then it's an insane amount of power. If you give yourself hundreds or thousands of years, you can let the sun kind of do its thing, and you can just mine, from concentrated brine, or you can mine from fully dried up deposits. Anyway, long story short, like these nuances matter, right? Because there has been the belief, though I think that belief is finally going away, because I think some people are finally facing some of the real resource limits. But like when the Gigafactory was announced, there was the kind of sense like, oh, we're going to use this batteries for grid storage. And it's like, no, I don't actually think that we will, because a kilogram of the battery materials in a consumer electronic device like an iPhone or a laptop is worth way more than a kilogram in an electric vehicle. A kilogram in an electric vehicle is worth way more than a kilogram in grid storage. So if you're going to run out by the time you do, 40, 50% of the electric, vehicles of the vehicles on the planet, then you're just not going to have any left over for grid storage. And why would you, apply your kilograms of rare material to something that's going to give you a fraction of the return? So that's fully going to be starved out. Now, at the end of the day, like, these nuances ultimately matter, because if we're not aware of those nuances, we will make the wrong policy choices, or we will make the wrong economic choices, the wrong investment choices. Sometimes that's not a big deal. Like, investments happen all the time. Sometimes they pan out, sometimes they don't. That's kind of normal part for the course. But I think like when we start talking about moving huge dollars to go incentivize this or incentivize that, where that the core physics or economics doesn't really line up that well in the nuances, then this is us from the opportunity cost perspective missing a really critical opportunity. Because the billions that went there don't get to go to something else that actually might be more physics or economically advisable.
Right. So if we're currently living in an extractive epoch where we're just trying to get more mined for fewer dollars.
Yeah. So the leverage comes from, if I can extract more from nature for fewer dollars, then I get more financial leverage. Yes.
Right. And what you're suggesting and also pointing to in terms of the nuance is where we're moving towards is now, how do we maximize the effectiveness with fewer inputs or use
so
fewer
the first
resources?
epoch is to move to what's called the mature productivity epoch. And that's not a made up term. It's actually a term from economics that has to do with like how much, GDP can you get per kilogram of material, or how much, useful economic output can you get for kilogram of material. I extended the concept as well to include, if you're going to go pollute, then how much useful economic output can you get per kilogram of pollution, right? Mm-hmm. So when and you can consider carbon dioxide a type of atmospheric pollution, at least for these purposes. Anyhow, long story short, like that's a different core of how you get more leverage. Like, as opposed to like, well, if I could cut down twice as many trees in the same hour, then I'm making more money. You say something instead like, well, if I could take the same amount of wood, like let's say I didn't cut down twice as many trees. What if I actually cut down half as many trees, but I got more economic output for half as many trees? Well, that's another way to get leverage. Now, it's not, it requires a bit more creativity than just like strip mining or like clear cutting and all these sorts of things. So, you can see how relatively uncreative that activity is. But when you get it right, then man, you change the balance for everything, right? Because if you got it so that in this particular industry, the inputs of, whatever material, like a critical metal, a rare earth metal, wood, paper pulp, whatever is going in as your input feedstock, if you can get 2 times, 5 times more economic output per kilogram coming in, then that typically resets how the whole industry goes. That's not just like, oh, my company cleared this mountaintop in less time. So I think it's both. You get extra leverage on that because you basically get leverage from doing more with less, and you get leverage over the entire industry in the process of doing so.
And the entire industry part is because it's able to economically scale?
Yeah, because that starts to outstrip the economics of the previous industry, right? If you had to pay for 5 times more feedstock than me because I'm way better at material productivity, then you're losing out actually ultimately economically. Even if you have great harvester machines that can harvest real fast and clear cut in less time, well, if you are stuck with the disadvantage of needing to actually use 5 times more material, we're going to beat you, right? So a lot of the investments in my firm are in this epoch right now where, for example, one of the largest water polluters on the planet is textile dyeing. And we always invest in what we call the triad. The triad is a disruptive deep tech, which ushers in radically better unit economics paired with radically better environmental economics. So on this one, it's called Alchemy Technologies. They're based in Cambridge, UK. But on this one, the tech itself is the new textile dyeing machine. The environmental economics is that it fully eliminates wastewater from textile dyeing. So that would go from one of the largest water polluters on the planet to nothing. And then on the unit economics side, OpEx, it's 2.5 to 3 times cheaper. So it means if you are not doing it the way that we are doing it within 10 years, we're probably putting you out of business. Right. But from the material productivity lens, it says for, per ounce of wastewater, per ounce of pollution in the water, then we are getting this much more economic output. So like a normal textile dyeing shop is basically dumping out metric tons of pollution every single day. Like we have de minimis pollution. We get a couple ounces when you change colors. So we're down to like a couple ounces in a week. And it's very easy to deal with, actually.
So to summarize, what I hear you saying is that @ONE Ventures is taking a look at disruptive technologies.
Right.
How do you apply those against?
And specifically disrupting the industries that are doing the most damage to nature.
Right. So engaging where there's the most damage to nature, and then improving, and dramatically as possible, the unit economics in order to do more with less.
Right. And a great way to win at unit economics, and very compatible with the current economic system, is to get really good at material productivity. So more economic output per kilogram of feedstock, more economic output for, necessary, evil of a kilogram of pollution.
Right.
Right.
And so the array of technologies that's currently happening, are there a lot of different types of technologies that are converging to enable this materials productivity? And maybe just paint a picture, especially for those who aren't as deep in the technical side, of, where do we stand in 2023 as the opportunity for materials productivity?
There's a huge number of opportunities. And if you wanted to have kind of a template to go and break it down, then one can understand the cost structure of anything to be 3 subcomponents: feedstock, processing, transport, logistics, right? And to the extent that, we have new material science, then that can oftentimes adjust what is needed from the feedstock perspective. To the extent that we have got things like machine vision and robotic automation, we can be way more skillful with the way that we work with materials. Also, if a lot of your cost structure is related to the labor fraction on the processing side, then obviously automation helps to reduce the labor fraction from the cost perspective.
Right.
And there's a whole suite of technologies. Like it's not just the stuff that's hypey in the news. It's actually very rarely something like a large language models, because they're just not reliable enough. Like hallucination is also equivalent to saying it is just fully wrong from time to time, and you don't know when it's wrong. So like and I think if you're like playing around with like authoring a chapter of a book or something, or like just, you want a writing assistant tool, then great, right? You're still mucking with it. You're still right there, like operators right there. But like when you're talking about like things needing to roll off a line at quality, you don't want a thing that has like random unpredictability inside of it. You don't want something that hallucinates. So I think there is an overhype on just the latest thing that people have heard about, when a lot of like really, foundational techniques around machine vision where you control the lighting condition, and you have, region or texture detection, or you do more classic, like specialized AI in order to be able to, classify different parts in a scene for a robot to be able to do something differently with it.
Mm-hmm.
Now, those are all relatively modern techniques as well, right? Like last 20, 25 years kind of techniques. But, but I do think that there's this mismatch in terms of like what's sexy. And then people are like, oh, the sexy thing must be the thing that solves the problem. That's obviously the wrong way to look at solving a problem.
Right.
Right.
So I guess the critique of stage one, this Epoch one, is that it's kind of just doing capitalism still. It's just about more efficiency. We're still in a growth paradigm.
Yeah.
We're trying to do more with less, but we're still doing more at the top line. How do you think about whether or not this really gets us to planetary health and regeneration, or maybe that's a segue?
So this doesn't flip you into being generative to nature yet. It basically says, well, hey, imagine you have so and so much global GDP, and it's providing so and so many goods and services to the people around the world. Imagine we could do that with 1/10 the footprint on water. Imagine we could do that with 1/20 the footprint on greenhouse gases and emissions. Imagine we could be more thoughtful about the mined materials and do it with a third of that or quarter of that. Now, these things are big moves, right? To go from one of the largest water polluters on the planet as an industry to nothing.
Totally,
that's a pretty big move.
Totally.
But like to your point, it certainly doesn't challenge capitalism at a core level, or the philosophy of capitalism on core level, which is honestly on purpose right now, right? Right now, you almost like want to aikido the big energy of capitalism to be able to get the changes to happen sooner than later. And this is, I can tell two little stories about this. Like one is like actually pretty depressing and one is not. What would you rather hear?
Both.
Oh, you want to hear both? Okay, here's the depressing one. Like when I was trying to go understand these ecological problems, I had a 1.5 year sabbatical where I traveled everywhere in the world, going to the places where the glaciers were calving at 100x the rate that they had been, 20 years prior. The places where they're clear cutting the Southeast Asian rainforest and putting up all these palm oil plantations. The places where they don't even bother even taking the timber from the Amazon anymore. They just slash and burn it for soybean and cattle. And then also a lot of villages where people live on $1 or $2 a day. And that's not even the main point of the story. The main point of the story is like, in order to go fund my sabbatical, I was doing some consulting work, like innovation consulting work with big corporations. And one of the folks I worked with is a large, Asian clothing manufacturer. They manufacture a lot of things, but they have manufactured for pretty much every clothing manufacturer that you've ever heard of, every brand you've heard of, they've made something for. So because of that, I can kind of guarantee that you almost definitely have articles in your closet that were manufactured by this company. They have 8,000 primary factories, 11,000 extended factories, and I spent some time with them trying to improve the sustainability of their supply chain. And given that, I can almost guarantee you that there's something in your closet that was not only sewed by an 8-year-old in Bangladesh, but was sewed by an 8-year-old in Bangladesh that was not paid. So that's not just child labor, that is child slave labor. And that said, I don't think a single one of those brands condones that. The manufacturer that I worked with does not condone that.
Right.
But like basically you order things and then sometimes those shops have subcontracted shops and whatever. You go like one nudge over and there's going to be an 8-year-old that hides when an inspector comes that is basically not being paid. Now, why in the world does that happen? Well, it turns out that the labor to go do a normal seam on just a normal cotton fabric is about 0.2 cents per seam. So a 7-seam t-shirt, which most t-shirts are 7 seams, is 1.4 cents of labor. That sounds pretty darn cheap. But you know what's cheaper than 1.4 cents? 0 cents. And capitalism in its current form, if it can find a better unit economic, in this case, 0 cents compared to 1.4 cents, which by the way is not that much labor to pay, but then it will go take it.
Right.
So I looked at this and was like, well, this is kind of one of the worst things in capitalism. And also look at how powerful this force is. Right. Even when people don't want to be a part of this, because I would tell you for sure the brands don't want to be involved in child slave labor. Right. The manufacturer I was working with absolutely was trying to root that out of the thing. So like, it was nobody's intention that
Right.
this happens.
It's not legal. It's not wanted. It's not part of the core values of the company.
Yes, and the force of capitalism still drives you in that direction anyhow.
Exactly.
So I looked at that and was like, well, at the end of the day, the actual root here is just winning at unit economics. So what if we could make it so that, the things where you win at unit economics are also the things where you win at environmental economics. So even if you could care less about the environment, that also comes along with it. Just like, people care a lot about, or at least they hope, that they don't encourage child labor or slave labor, all that kind of thing. That comes along with it because capitalism. Then like imagine, the thing that came along with it because capitalism was a massive reduction in water pollution, a massive improvement in energy efficiency, a massive reduction in emissions. And what we've seen is that, roughly 95% of the customers of our portfolio companies honestly are buying from us and they don't care about the environment at all.
Wow.
They just want better unit economics. And that to me is like the whole mission in play, where capitalism, in this case, you're using like Aikido style, the energy of capitalism that will, have an 8-year-old like sew their fingers together, in Bangladesh. We're using that same energy to get useful things out in the world. Now, I would love to go challenge, the paradigm more foundationally, but I actually have a pushback on the folks that are like, oh, late stage capitalism must be torn down. The whole system must be abolished. I think that like there's probably not a world where we succeed at that. And that the better metaphor, and metaphors matter because it does shape the way that we think about the problem and therefore approach the problem, and what we consider to be a win or not. But I think the better metaphor is we need to compost late stage capitalism, right? There's a lot of nutrients in there. There's actually some parts of the system that work all right. For what it is, it works all right. So just like, the nutrients in a tree all get recycled by nature to go create that new ecosystem. You don't just literally, like tear it down and drag it away and leave nothing for that ecosystem. Then the nutrients in late stage capitalism need to be decomposed, reformed, put into these useful forms. And just the way that a tree, a fallen log starts to decompose, it doesn't like happen everywhere all at once. It's like, oh, some fungi got into this little corner and now they're doing their thing. And now they're breaking down the structure a bit and that making things, available to next decomposers and next and like different parts of it. So what we'll see as we compost late stage capitalism is the little pockets that are a little softer, and we'll start to be able to move the nutrients in that system in a more thoughtful way. Right. And they'll be like, oh, this part is now leading to some new growth.
Right.
So cool. Let's not touch that. Like, let's not fret that a log fell, right? Like some good stuff is coming up here. And then some other spot will come up, right? So it'll be not just like a flip of the switch or, like revolution. We stormed, like whatever, the palace or whatever. It will probably be a bunch of like, vignettes of decomposition,
right,
and composting back into a new useful form.
Right. So I'm tracking you there, and I love the metaphor of composting. I guess one of my major concerns is it feels like one of those aspects of late stage capitalism that's working really well is venture funding for new technology, the ability to bring a lot of resources forward to fund innovation and disruption. And in this case, hallelujah, we're aligning better ecological economics with better unit economics and technology. However, if we look at the full stages of growth of these companies, usually after, say, 10 years, 15 years, and so forth, a lot of capitalism's tendencies end up leading towards regulatory capture, over-financialization of these companies. Some would say a lot of the evils of our world are due to the very big behemoth, multinational corporations that have been around for a long time. So how do you, as you're, doing this from a venture lens, ensure that 10, 15, 20 years out, the companies that you're funding now don't become the problem in the future?
Yeah. I mean, actually, I will kind of probe into the question a couple of different ways. The first one is venture working that well? I mean, venture is working, But I don't actually think it's working that well.
Yeah.
It's one of the few disciplines that we haven't gotten way better at over time, right? If you think about what electrical, so I'm formally trained in physics and electrical engineering with a specialization in robotics and signal processing, built a lot of things in my life. It's cool. But if you think about how electrical engineering has changed from 50 years ago till now, we got a lot better at it, right? Like the sophistication of devices, what they can do, like the size to which we can produce transistors and traces and the thing, all the sensors we've been able to make, it's amazingly better. And actually it's true of almost any discipline. Like compared to how it was run 50 years ago to now, it's improved a lot.
Sure.
But if you look at venture 50 years ago compared to now, it's basically the same, right? Maybe we're actually even a bit worse than before. Cause when Kleiner basically broke off as part of the Traders 8 and started, Kleiner Perkins, and was like one of the things that created venture, then those were highly technical people that understood how to invest in technical things. They spun off from a semiconductor company. And that's why it's called Silicon Valley. All we did was hardware investment. And now you zoom in today, it's like, oh, hardware's too hard. Like we can't do anything like that. Well, sorry guys, most of what needs to be improved for the industrial economy is physical hardware, right? Not always electronic devices. Sometimes it's a steel mill, a cement plant, all that sort of thing. But it's all physical at a level where you want the kind of expertise like the folks that broke off from Fairchild Semiconductor. Like you want that type of expertise in the room. And instead we've gotten worse as a discipline where all that's left is people that like have a little bit of software background or, only finance background. And they sit around like terrified, like, well, it's all got to be enterprise SaaS. Otherwise you can't make venture returns. Well, what did we do for the first 30 years? Right. Why is the place called Silicon Valley and not Lines of Code or Enterprise SaaS Valley, right? It's called Silicon Valley because all we did was hardware. And actually we did a lot more change to the world because of the hardware. Yeah. All of us have devices in our pockets now. All of us have multiple computers per person because we worked on a physical thing.
Yeah, and all the concentration of returns seems to be increasing in a way that it's no longer, 1 in 10 of these will work. It's actually like 1 in 100 makes all of the returns. And so
we got worse at software too. So like Google was venture backed and Airbnb was venture backed. But Google in its entire history over all of its rounds raised less than 200 million. So that's seed A, B, C, D, E, F, Dutch auction, all this kind of stuff. And that all happened for less than $200 million. Airbnb has raised, I believe, $6 billion. Now, does anybody believe that Airbnb is 30 times harder to write as a piece of software than Google? Like Google literally indexes all the information in the world. Airbnb is like a listing site. So obviously we got way worse at it. And obviously Airbnb is a way worse business. And I'm actually picking one of the success stories, right? Like there's a lot of major failure stories where they spent a huge amount of money and produced even less than Airbnb. But how did we get 30 times worse at software during that time span? Right? Like as everybody piled into software because it's the only way to make money, shouldn't we have gotten way better because there were so many more skilled people in the space? But we did the opposite. It basically attracted a bunch of capital looking for an easy buck. It brought less disciplined people into the space. They got as excited about a listing site as they did about something that indexes all the information in the world. And they were willing to pay, have 30 times less capital efficiency in the building of the thing. It's actually more than 30x because the business outcome is way worse too. So when you like loop in the magnitude of the business that it became compared to the magnitude of the business that Airbnb became versus the dollars that went in to go make that software, we're way more than 100x worse.
Right. So let me restate the question because I appreciate the pushback. And I guess from the context in which I was coming, it's like when you look at the ability for the public sector or for the philanthropic sector to fund innovation right now, it seems like it really falls short of what venture-style investing can do. And I guess part of the implication of you taking a venture model is you think there's some merits to the approach.
I'll tell you why I did venture, because basically there are things where the rate of change is appropriate for the task and others where it's not. A lot of times in environmental regulations, like there'll be a compound which is like clearly dangerous for the environment. And then the EPA wants to go regulate it. and it takes a couple years. They draft a bill, laws pass, and the EPA tries to go enforce it. That entire thing from start to finish might take 7 years, to be able to go pass a law to be able to address, some dangerous compound. Well, then the chemical industry hears, oh, this molecule is banned now. And it takes them like 3 months to go synthesize something that basically does the same damage, but is not exactly the same molecule. Oh, we added a hydroxyl group. Oh, we put in a double bond here, to the nitrogen instead of so-and-so, right? But like the messy end of it that creates the environmental toxicity is still the same. But it's a different molecule, not banned. So if it takes you 7 years to pass that, and it takes 3 months to like break it, then I can tell you who wins already. It's not a fair game, right? Because I can break your regulation in 3 months. It takes you 7 years to do it. Like there's a concept I call rates, not states, right? People always bemoan the state of the world, but they forget that the world is the way that it is because of the rates at which things happen. The reason that we haven't just gotten on top of regulatory for all the damaging things in our environment, including in the food system, endocrine disrupting flame retardants in our clothes and just on, is because the regulatory thing is like a 7-year push, 5, 7, 10 year. And then the workaround molecularly is like a 3 to 4 month push. So like rates are more important than states. Rates will define what the states will become, or they define why the states are the way that they are. So the reason for venture then is it is a place with a very high rate of change around capital and technology. And I wanted to go park in a space where the rate of change was appropriate and faster than the other things that need to change.
Right.
That doesn't mean that venture like works so great, but it is one of the few places where the rates are higher, at least.
Sure.
Yeah.
So any reflections on that earlier part about then?
Oh yeah. So about the regulatory capture and the other, nasty parts of capitalism. I think that's probably just part of it for a bit. Like what I will say is that are two different things. One is that as you build technology, and look, your patents only last for so long, things will get copied, things will get democratized. So there'll be things that you invest in where over time it becomes democratized, right? Like there was a point where the only smartphone came from Apple. Well, now a lot of people have a smartphone and they're actually relatively inexpensive, right? So there was a point where like even a massive breakthrough where people had a huge, head start, people catch up, it gets democratized, the prices come down, and that aspect of it helps to even things out a little bit. But around regulatory capture and a bunch of these things in the playbook, that's probably continue to be in the playbook until somebody outlaws it. And generally speaking, like you can back founders where that's not, in the spirit of what they want to do. And a lot of times people, grew up a particular way, they have values that they have, and they will stick with the spirit, right? Of how you knew them to be when you invested. And that's kind of the most that you can do. But like sometimes you back folks and either the spirit or their values change, or you discover that there's like some aspect of them which is about like total control of a thing as opposed to, just making a great product or service and profiting from having made something great for the world. So that'll probably be a part of it for a while until, similarly, there's going to be money in politics at an inordinate degree until we do something about Citizens United. There's going to be, an inordinate amount of regulatory capture until we do something about, antitrust at this type of level, right?
So we're composting late stage capitalism. We have things to do also from a policy and legal framework as well. But I want to get back to the second epoch and how do we get back to generative and regeneration and ecological health as a vision?
Yeah, I think that's a good prompt because basically Epoch 1, you're still not being actively generative to the planet. You're just getting a lot more benefit per extracted kilogram or for polluting kilogram. So still useful, but you're not going to become a net positive to nature like that. So Epoch 2, and that was Epoch 1. So Epoch 2 is actually a pretty big leap. It's basically finding leverage not from extraction or material productivity, but it's finding leverage from from working with the metabolic flows of nature. Because it turns out that nature is able to go produce all these things that we grow and mine and then use for our economy because it's a metabolism. It's not just a static thing. It's not like there was a set number of forests in the world and that's all there will ever be in the world, and we all cut them down and there will never be another tree, right? Like obviously trees grow because they're a part of a kind of a terrestrial biomass metabolic process. And another way that one could approach leverage is to actually basically say, well, what are the ingredients that drive the metabolism that leads to a healthy forest? If I could do a little bit of upstream investment in the hydrological function of the land and the soil function of the land and, things like this, being in an area with clean air, then you can drive a really healthy metabolism. And just like any other type of financial leverage, for a very small amount of investment, you can go create something that creates an ongoing, large amount of economic output or even an economic annuity of some form. Now, that requires us to stop thinking about the market as a bunch of nouns that are being traded. And that's a very big conceptual shift, right? We think about a stock as a noun. It's a unit of a company, right? We think about the goods and services that move around from a company really as a bunch of nouns. Even though services imply verbs already, we think about them as nouns because we want to move them around in these discrete transactions and so on and so forth.
Resources, commodities,
exactly,
stocks.
Right?
Yeah.
Like even the basic definition of economics in in school, they're like, oh, the efficient, deployment of resources, and they think about resources in a noun context. So it is a foundationally different thought to understand that all of the riches of the world came from verbs. And if you spend the time to understand how the verbs work, then you can get huge amount of leverage. And we've actually seen this many times in human history, but not in the modern era through the Industrial Revolution, because the Industrial Revolution took these different assumptions at the baseline. We could take other assumptions. It's actually not harder to engineer for something at Epoch 2, but we would need to build it off of a different conceptual base. And it's actually more of a psychological barrier than an engineering or physical barrier to go do that. And the reason I say this is there's been many indigenous cultures that have successfully been able to work with the metabolics. So for example, I live in San Francisco, I also live in Hawaii, and the ancient Hawaiians basically had a way of dividing the land into what are called moku and ahupua'a. So the moku are like the large watersheds, and the ahupua'a are like these tiny pie-shaped slices of like little micro watersheds. And it basically is, prototypically, it's like a little thin pie-shaped slice that goes all the way up to the peak of the mountain, and then the pie expands out to like a little slice of the shore. Now, the way that they cut this up is they cut it up so that, it's all based on the watershed. If you drop a drop at the top of this pie, it's going to exit somewhere at the bottom of the pie. So there's no such, and they assign the management of land and the ownership and use of land in that way. So there was no world where if you and your community was managing that pie slice, that you could do some pollution upstream and hurt some people downstream. You are the person downstream. And that itself basically led them to a verb understanding of that land, where it's like, we get a certain amount of rain here, the water's moving across the landscape in a certain way, it's quite precious, we want to do everything that we can with it on the way down. And that led to food systems, land management systems that not only were productive, it actually improved the net productivity of the land, even compared to what nature had already created there. But it did so in a way that actually expanded access to habitat and regional biodiversity, expanded, like food production, expanded all these things. And the Hawaiians were able to just go and, the kingdom of Hawaii had over 1 million people in it. And it had no imported food, no imported energy, all this, everybody was self-sufficient. The state of Hawaii has about 2 million people in it, and we barge in a bunch of oil for 85% of our energy, and we import most of our food. It's maddening. Actually, we are less productive right now than we were in terms of the actual agricultural output compared to what we were in the indigenous system. And it's not because the indigenous folks spent more time farming either. They actually just worked with the metabolics of nature in such a way that nature was creating a lot of productivity for them.
I was just in Hawaii recently, and I was just blown away at how much the percentage of food that's imported. Like,
it doesn't need to be. The thing is amazingly fertile island, and it supported a huge population when they managed the land in this thoughtful way, paying attention to the metabolics of nature. And they made it so that like life was actually honestly, there will always be some hardships in life, but life was actually easier than life today in Hawaii. Because the terminus of this stuff is like, so imagine it's going down to shore. You have some upland, wood trees and fruit trees and all that sort of thing. You got some downland taro fields. And then right near the shore, you have what are called a Hawaiian fish pond. And the way that Hawaiian fish pond works is you basically build a little lava rock wall, stone by stone, and it basically encloses almost like your own little bay right next to the shore. And then you leave a little hole in the rock wall, which basically has got like a slatted grate inside of it. Now, the way that it works is that the grate is thin enough that baby fish can swim into the fish pond. But once they live there for a little bit and fatten up, they can't swim out.
Never.
And what it also means is that when those fish breed at adulthood, their little babies swim back out to the ocean. So there actually is no net drag down of the ocean. But what's nice about the fish pond is it's consistently relatively shallow. They made it so that the whole thing is between like 2 to 5 feet deep. So the kind of thing that you can just wade into and do stuff with. And it actually meant that their fishing happened through something that's called a lay net. And for folks that aren't familiar, a lay net is you go out with your friend in the water and you put a net down and then you just leave for an hour. And then an hour later you come back and you lift up the net and there's fish in it. I cannot imagine an easier way to fish. And it's like incredibly productive. It didn't create any net drag in terms of the life cycle of those fish. They were giving back to the ocean by actually creating a relatively safe haven for these adults to be able to go breed and provide more spawn back to the ocean. And they basically had a consistent, reliable, and easy source of protein. It's honestly easier than going to the grocery store.
So I guess what you're suggesting with the epochs, to bring it back, is epoch zero, the extractive economy we currently live in. We're saying, how do we catch more fish with the current
how do we use a trawler to get all the fish with one run? And that doesn't matter if there's no fish next year.
Right. And Epoch 1 is more about like, how do we get more nutrient density or more caloric intake from the same fish?
For the same fish, can I also sell the fish oil and have more productivity from the fish oil? Can I use the skins for something and sell it for that? Can I, whatever. So you're getting more out of it. And can I valorize it, right? Maybe there are cuts of, the fish that are the really high quality sashimi cuts. And then there's other parts which are meant to be mashed up into cat food. And there's other parts that are some other thing, right? So material productivity would say, well, how do we get the most out of this thing? Yeah.
Right. And then Epoch 2, enriching,
is basically, let's heal the hydrological cycle and work with it in such a way. And let's work with the metabolics of how the ocean wants to produce, wildlife and animals. And by nudging the metabolisms a little bit, they're able to get huge economic output. So once again, financial leverage, just like every other type of financial leverage, but needing to take an extra step back to understand the verb that created the wealth and support the verb that created the wealth, as opposed to go and clear cut or mountaintop remove the wealth that's there.
And what are maybe some contemporary examples of how this is manifesting from a technical and economic lens for you and at One Ventures?
Yeah, so we have some things that are operating at Epoch too. So, so one of our companies, Dendra Systems, is the lowest cost way to restore ecosystems on the planet. And one of the things that they are really good at is mangrove restoration. And it plants from drones. We can plant 120 mangrove plants per minute per drone. So it's actually quite fast and quite good at what it does, with a super high survival rate, like 85 to 95%, germination through full survival. In this particular case, like Like, well, what do you use that for? Because it doesn't plug into the regular economy. Well, we ran into a situation where basically a government realized the importance of the metabolics. And, the specific example I'll share is we did a bunch of mangrove restoration in Myanmar. Now, what happened in Myanmar? Well, the Myanmar government, in the name of economic development, basically cleared a bunch of coastal mangroves in order to set up shrimp fisheries. And they're like, oh, this is going to help the people in southern Myanmar. We're going to improve the economic base so much. Da, da, da. What it actually did is it made it so that all these people that did subsistence fishing amongst the mangroves were now starving. Because you actually killed the main place that they're getting their protein from. And sure, there was grains and other things that they could eat, but they were getting malnourished and starving. Mm-hmm. And all of a sudden, the government, it's not the best thing for you to just have mass starvation in your country. So now all of a sudden, the government was on the hook to provide some government services so these people wouldn't starve. And at some point, they realized that it would be cheaper for us to repair the metabolics of this system than it would be to keep on, doling out government services because you're starving now. Mm-hmm. So I think we're getting little peaks
totally
into understanding this. But when I say it's a conceptual leap, it's a pretty big conceptual leap to go from the noun to the verb. I mean, I can go explain it, in a minute or two. But I think because we're so de facto used to, the economy is built off of nouns that are traded in particular ways. And if you can extract more of that noun for fewer dollars or less time or whatever, then that's the only way to get financial leverage, right? Then because of the mindset issues, we run into problems. Now, if you talk with the folks that created those indigenous land systems, they have trouble trying to understand it this way, right? The reason that Manhattan got traded for some beads or whatever, they're like, I don't think it means anything to own land, right? And because actually the sensibility of, not just those native people, but many native people is that the people belong to the land, not vice versa. Mm-hmm. So the idea of a human owning a thing that actually you belong to, it didn't click at all. So we created, half of the prison is mental here. That's my point. Right? We can talk about the physical things to change, like these wind turbines and solar arrays and electrification of things and the decarbonization of industrial process heat industries. And we can get into lots of details on all that stuff. And there is a lot of real physical work to do, physics, engineering, chemistry, all these sorts of things to actually do. But we oftentimes ignore the mental work. And that jump is a really big jump, even though it's like the 1,000-year, 30-second jump. Because it honestly only takes about 30 seconds to explain the concept. But it might take us 1,000 years to actually fully incorporate it. I hope it takes less time than that, but it's been taking a long ass time. Yeah.
Any thoughts or ideas around how do we accelerate that mindset shift?
I think similar to the composting and late stage capitalism, you just need to show enough examples of it, right? That company, Dendra, actually just won a $50 million contract to restore the mangroves of Abu Dhabi. Well, now you start top lining $50 million, people are like, oh, that's kind of sounding like a business, right? Now, of course, we had a bunch of recurring revenue ahead of that. This is just the latest contract. But you look at that and you're like, oh, shoot, there must be something you can do there. Well, how does this thing work? Oh, you're not just trading some kind of good or commodity. Oh, you're doing what? Oh, you're supporting the basic metabolics of that ecosystem. Well, what does that do? Well, for Abu Dhabi, it's actually really clear. They destroyed these coastal ecosystems and now they're dredging up all this sand, trying to go repair their beaches. Mm-hmm. And the dredging of sand and the moving all that stuff around is costing them billions of dollars. Right. Compared to 50 million to just repair the ecosystem and just have that stuff as a service effectively for free. I mean, nature's doing work. Mm-hmm. It's photosynthesizing, the roots are holding, preventing erosion. Bunch of useful work is being done. But I think we're now finally starting to recognize that there actually are oftentimes more financial leverage in the investment in the verb as opposed to this noun concept that we fully created, right? It's less true than the verb story. The verb story is actually how nature produces all the wealth. Right. The noun story is a localized story that we created so that we could encourage the idea of ownership. Because it's easier to imagine the ownership of a noun than the ownership of the verb of a watershed.
Mm.
But that said, the reason I mentioned the ancient Hawaiians is they worked out a way to effectively create a sense of personal ownership, not like oh, I'm going to mortgage this or something, but like in terms of responsibility, a personal ownership over the verb of a watershed.
Right. I'm really curious to this question of like, what's it going to take to catalyze change? And in Epoch 1, when you described the materials productivity, you said that a lot of the portfolio companies' customers, maybe, a vast majority, are not doing it for ecological reasons, but economic reasons. And here, when you're describing these examples in Myanmar and Abu Dhabi, in both cases, it sounds like what you're saying is there's a realization that they're spending more money doing all of these other downstream effects. And so rather than that, fix the mangroves, for example, and that will help to reduce all these other government services, which, said another way is like, again, the language of finance is what's catalyzing the change rather than somehow this paradigm shift towards verbs versus nouns. And that we're beginning a journey.
I don't think that we're going to win philosophically first.
Right.
You're going to win economically first, and then people will be like, how did that work? Mm-hmm. And this is actually true of kind of everything, right? Like people are super scared of investing in a space and venture until somebody has $1 billion exit. And then everybody's like, oh, it's obvious that this is a great sector. Mm-hmm. Well, if you talk to those same people 2 years prior, they're like, oh, that's a real dangerous sector. Right. Like you might lose your shirt in there. And it's like, yeah. So like the stuff moves forward through existence proofs. Mm-hmm. It doesn't move forward through like somebody winning a philosophical battle.
Right.
Now, I think if you have thought about what you're trying to do philosophically with a little bit more depth, you give the possibility of a longer, runway for you to do something amazing with it. Mm. Like if the ceiling of your concept is, well, let's just extract all the stuff from this mountaintop, then, you get the world that we have right now.
Right.
But if the ceiling is, let's go support the basic metabolics of nature, like the root that creates all the wealth, then the ceiling of that concept is way higher than the previous ceiling. Now, at the end of the day, I'm not going to convince you conceptually of it. Like we're just going to have a bunch of companies that start making 50, 100, 200, $1 billion, right? And then they will be working off of something that is got a higher philosophical ceiling, which means larger potential upside in the long run, but also in the near run, it means we can just show these existence proofs. And then, in a Harvard Business Review case study, they'll like decompose and be like, oh, this leads us to a fantastic observation that at the core of it, they're working with verbs and not nouns. It's like, I could have told you that at the beginning, but you won't believe it until you take apart the engine yourself and be like, oh, that's how they made all this money. Okay, I got it.
Mm. Right. Well, I mean, enriching ecosystem metabolics, which is how you framed it for this
Epoch, yeah.
Epoch 2. And I like also what you said of that humans can become the keystone species that takes care of the other keystone species.
That's right.
What does that mean?
So animals have a huge amount of influence on the plant biomass. So like wildebeest in Africa, it could be an herbivore like a wildebeest in Africa or a buffalo in North America, and some parts of Europe also had buffaloes. Or it could be like a predator, like the wolf in Yellowstone. Right, we've seen the wolf in Yellowstone in the Western state basically, recast the trophic cascade in a way that is way healthier in terms of the diversity of species that are on that landscape. The balance of populations that are in that landscape are in way better harmony. So keystone species are species that their presence on the landscape dramatically improves the health of that ecosystem in a way which is massively beyond just their day-to-day activities for themselves. And what it means to become a keystone species that takes care of keystone species is we as well could do relatively small amounts of care, which allows these keystone species to go off and do their amazing thing and kick butt at the whole thing. So like right now we're spending billions of dollars on direct air capture plants, but it turns out that a technology that also sequesters a bunch of carbon is a beaver. Because a beaver will go make a dam, and a dam basically creates a wetland behind the dam, and wetlands basically gather a lot of carbon through anoxic decay. So you basically have particulate biological matter inside of the water, and you basically have but basically the dam encourages sedimentation, which anoxically decays the biological material that's in the water, and then leads to a hugely rich, in carbon soil, basically at the base of a wetland. And this is why a lot of our existing oil and gas deposits were historical wetlands, right? These are ecosystems that accumulate and capture carbon at way higher intensity per acre than most other places. Now, a beaver does this for free. But like when we do it with a direct air capture plant, it costs us billions of dollars. Mm-hmm. For us,
beavers produce more beavers.
Yes, beavers also, actually the maintenance cost of beavers gets lower over time. Because as the ecosystem gets healthier, they're like, oh, well, I don't need anything anymore. I'll just make some more beavers and they'll go down the river and do another one. Mm-hmm. And, those kids will go down the river and do another one. So like, DJ Khaleding the thing. But like but I think we're sitting here in this fully short-sighted way, like being like, well, how do we get another 10 billion into direct air capture? Mm-hmm. Not understanding that like, yeah, you could get the same amount of capture, with a couple hundred beavers, and it's way cheaper than $4 billion, $3 billion, which is a lot of the plants that we're talking about on the DAC side are between $1 to $5 billion.
Mm-hmm. And so efforts, dare I go into this topic of carbon, but efforts to address that is, well, there's no money in conservation or restoration of habitats for beavers right now. And so
there's apparently money for carbon, and we'll spend hundreds of dollars per ton for something that, we built $1 billion machine to go grab.
Right.
Which, by the way, doesn't pay itself back very easily when you think about how much went in, unless the thing is insanely priced per ton on the carbon side, right?
Sure.
Just think about how long it took you to pay back the $1 billion. As opposed to beaver, we could just kind of do the thing for free. Now, if we actually think that carbon is worth money, then we can pretend pay the beavers.
Right.
Right? Like however you want to cast it.
Right. So do you think that's a viable model to suggest, if we have the appropriate verification tools and feedback loops, that pricing carbon in the financial system in a way that can therefore incentivize, for instance, bringing beavers back? And when we have the right measurements and clear-eyed, evidence-based approaches, we'll see that, beavers are far more important than, multi-billion-dollar direct air capture plants. Do you think that that's a way to reform the financial system and that has legs? Or, obviously carbon credits are getting a tremendous amount of pushback right now and a lot of criticism. So curious to open that topic a bit.
Oh, there's some nuances to it.
Of course.
And specifically, like, the carbon market is designed fully incorrectly. It should not be a system with credits that are tradable.
Right.
Right? Because it basically means, well, you can pollute and then go buy my good behavior, in order to allow you to pollute. And that just creates a lot of adverse incentives.
So they should just be retired upon purchase?
We have successfully decommissioned molecules from the industrial system. And when we have done it, it has typically been a polluter pays type approach. Mm-hmm. So in the Montreal Accord, which basically helped to close the hole in the ozone by banning CFCs, it's polluter pays, right? When we banned DDT, because we saw that it bioaccumulates and screws up, a bunch of the top organisms in a bunch of ecosystems, then we banned it, and basically is a polluter pay kind of principle. Mm-hmm. Now, polluter pay doesn't like shut down all of industry on day one, but it basically says, imagine there's like a 20% cost increase over the next 4 years if you keep using that molecule. And then at year 5, that's going to jump up to 50% more expensive. Then on year 10, it's going to jump up to 200% more expensive. Well, there'll be some point where you want to get off that train. And if you know exactly when the hikes are coming, then you plan for it. Mm-hmm. And that's exactly what happened with CFCs and all these other things. Like, people knew the thresholds and when it was coming. And industry is actually quite quick at being able to work backwards, knowing that they would need to pay a lot more for that pollution in the future. Mm-hmm. They just engineered it out of their system really quickly. That means industry is fully capable of the transition.
So that would, if we did a polluter pay model for carbon moving forward, that takes care of the. Well,
there's two parts. There's polluter pays, mm-hmm. and sequesterer gets paid.
Gotcha.
But you shouldn't allow them to be traded.
Right.
Yeah.
And so sequester gets paid. Do you feel like carbon credits is the viable financial pathway for that, or what's your take?
Right now, it doesn't look like it because the first rev of this is just a bunch of financial engineers or a lot of financial engineers that, want to sit in an office in Midtown and draw a KML file and get paid millions of dollars, right? The malaise is of this current iteration of it is that nobody wants to get their boots sturdy.
Mm-hmm.
There are people that want to sell you on some crypto blockchain or coin offering, to reforest Zimbabwe. They've never stepped a foot in Zimbabwe. And it's like, guys, when do you get your boots dirty? I mean, it's not even that dirty to set a foot in the country,
mm-hmm.
but it's like, for sure people, people aren't even doing that minimum level. And for sure, they're not doing the deeper level of what does it actually take to restore a landscape? Well, because I work with, in our portfolio, we have multiple things that are about ecosystem restoration, then I actually see what it looks like to get the boots dirty. And the thing is that it's actually fully tractable, right? Just like anything that we make, it's fully tractable. But is manufacturing, apparently harder than writing some software? Absolutely. And because of that, then we have a whole industry where it's like, well, software is easy. We just all the money go to software as opposed to industry. And it's like, well, that's dumb. And in the same way, is it easier to sit in an office in Midtown and draw a KML file as opposed to sending somebody to go plant some mangroves or actually go and survey a landscape to go ground truth a thing?
Mm-hmm.
Yeah, of course, it's a bit harder, but that's actually what the work is.
Mm-hmm.
It's almost like if you're trying to say would it be easier to copy all the stuff, on a test for your homework and your tests and just submit that and you get the grade? Yeah, that's easier than learning the subject.
Mm-hmm.
But the work is actually learning the subject. And you have none of the capabilities that you want if you cheated on the test. So similarly, we have a bunch of people that are metaphorically cheating on the test relative to the carbon markets.
Mm-hmm.
And I think it's extremely welcome to have a backlash.
Yep.
Because imagine the test where the teacher lets everybody cheat.
Mm-hmm.
Well, the people that are actually working hard at it is what gives, man?
Yep.
I studied 20 hours for this test.
I guess the counter argument, when we look at people, indigenous folks stewarding Amazonian rainforest, for example, and there's no financial incentive that's currently being provided for the maintenance of protection, only for extraction and logging and whatnot. And, the inevitability of needing some basic financial resources to participate in basic health and education services, for example. And you can say that the carbon markets are really failing to meet those needs. And I think that's accurate because, carbon markets are constructed around things like additionality that are difficult to prove in those contexts and so forth. But I think people who may not be, just the Manhattan, trying to clock it in and make millions of dollars, but are actually earnestly working on the problem would say, we're continuing to iterate the system. And just because it's not there yet doesn't mean we should throw it out. We just need to continue to improve because the core basic idea that sequestration of carbon should be financially incentivized is still fundamentally sound. And just to bring a different example in, because my boots aren't muddy from the Amazon rainforest as much as they're muddy from the farm I helped steward in New Zealand. And this was a former dairy farm, and there was a generation or two of practices that was traditional dairy farming practices, and that meant animals in the water. That meant cleared out trees from all of the rivers. We know, ecologically speaking, that riparian planting is really beneficial to the landscape and fencing off those waterways. We have a lot of waterways that we need to fence off. We have a lot of trees to plant. There's absolutely nothing either in the carbon markets today or in any other financial mechanism that gives us as a farm some sort of way to cover those costs.
Yep.
And so, are we going to be in a situation where it's like what happened in Abu Dhabi, where you get these large-scale government financing programs, which has its own slew of challenges and unintended side effects if we're only using those financial instruments? Or are we going to be able to construct markets that recognize ecosystem service value, so to speak, and maybe we're thinking not just carbon credits, but other water and biodiversity value and so forth. Or is that fundamental architecture just plain wrong for any deeper reasons? And I'm just really curious your take.
I think there's a couple questions actually embedded in there. Like I actually fully believe that people will be able to understand the metabolics argument once they actually just see more examples of it.
Totally.
Because I'm going to say that these were not enlightened national governments. Remember, they cleared all the stuff in the first place. But then they're like, man, it's real economically disadvantaged to go do this thing that we did. So, they corrected themselves effectively, fully on economic terms, once there was something that could show them that there was actually a better economic way to go do it. Right. So,
but that would imply that it's more of a government public sector grant type of financing relationship rather than kind of a free market or market.
No, I think it's more than that as well. Like governments in that case, it's like, well, people are starving. We got to do something, right? But like with companies, like you're talking about riparian planting, kind of stabilize like the flow of the river. Obviously, if it all gets grazed away, river gets wily too, or doesn't flow the way that is healthiest for the landscape. Well, think about the landowner. They are not the federal government, but like if they want to stay in farming for an extended period of time, right? If you want the land that you is part of like the generational wealth of your family to be worth something for the next generation, then you would also think about this. So I don't think that this is something that is a million miles away as a concept. That's why I'm saying it's like a 30-second jump that still might take us hundreds of years or thousands of years to take on as a civilization. It's not conceptually hard for people to get. But like they just need to have a lived experience of it where it's like, oh yeah, the second generation managed it kind of poorly and we've been repairing it since, 1989, since right? The third generation got a hold of it. And now we're pretty much back to where we were, but it's real tough. Look, we saw that with the Dust Bowl. We're like, hey, we just go out there, do this thing. And all these farmers very clearly economically understood that this is not how you do it. Right? Now, so you hope to avoid huge tragedies like that. Because once again, people starving, waiting in bread lines, all that kind of thing for that one. But like, so you hope to do that. But both at the national level and down to like the family farm level, people do notice these things. It's just, can we have enough experiences of that so that people can make that 30-second conceptual jump and be like, no, it would actually just be useful to manage the river here a bit and in a more thoughtful way.
Yeah, I guess I'm just torn because I'd like to believe we take in data and feedback loops and correct our behavior. And then I also feel like we're not doing that.
We're not doing that. A lot of it is because of the system design. Because remember, we already did the CFCs, we already did DDT, we already got lead out of gasoline, we already did a bunch of things where something was at huge industrial scale and we brought it to zero, right? There's still occasional lead in gasoline, but whatever. Like for the most part, we have successfully, and these are all recent examples. These are all examples that largely happened in the 80s. So not like ancient history, not in a completely different time. So I point to them because we actually know how to do it. But the reason that it's not happening is, I remember the stat from COP26 was that like 70% of the actual seats inside of COP were for oil and gas folks. It's like, that's the wrong people to do this. Right? Now, look, I'm not saying that those people could never have the wherewithal, but they've certainly been talking about doing it for a long time and have gotten way less done than earnest people that have way less money. So I'm just going to say if they do have the wherewithal, they're certainly not practicing it at any degree that matters right now. And then you give them 2/3 of the seats inside of the main conference where we're trying to solve the thing. It's just it's like getting a bunch of whalers to like try to end the whaling industry. And actually, I mentioned that industry specifically because 100 years ago, whaling was one of the biggest industries on planet Earth. And, if we had kept on whaling for another 25 years, we would have extincted whales from the planet. We had already brought down the population of many commercial whales by 80, 90, 95%, during the whaling era. And because whales take a long time to grow and gestate and get to sexual maturity or whatever, we're still hurting from that, even though it was 100 years ago. And we basically took these sentient beings, because now we understand that whales like name their young, they have culture, they have special songs that they pass around, almost like the popular songs of the day. They're like obviously deeply sentient beings. And we turn these sentient beings into lamp oil and lipstick. To me, that's like some Holocaust level shit, right? Where we basically took all these human beings and we turned them into soap, and we got the gold out of their teeth and melted it down for Nazi gold. And like, I am never going to shed a tear that we ended the whaling industry, right? And the nice way to go say what our firm does is we help humanity become a net positive nature. The meaner way to say it, though kind of equally true, is we're looking to disrupt and destroy the industries that are destroying nature. And that sounds really harsh, but I will never shed a tear that whaling is gone. And I think 100 years from now, we're going to look at a lot of the industries that are here today, and we're going to understand them to basically be the same as whaling. That the amount of death and destruction that we were driving, the irreversible arrow of extinction that we were driving through those activities was fully unacceptable. But like, if you skip back to those days, there was moral people, but they were using whales for their lamp oil and their lipstick. So like, we will look back, 100 years from now, people will look back and it's like, they did what? Totally. They made all that plastic just for a thing they throw away in 2 seconds? Mm-hmm. That doesn't seem right?
Right. And in that 100 years, what does Epoch 3 look like?
Oh yeah, Epoch 3 is the third and hardest one, but it is basically fully getting aligned with the way that life works in the universe. So the purpose of life in the universe is to maximize diverse nutrient flows and to savor every photon and savor every water molecule toward the goal of maximizing diverse nutrient flows. And we see this with the arrow of life on Earth, period. You start out in the early stage of planet Earth. We only have single-celled organisms, no multicellular, no complex life, none of that for a couple billion years, actually. Mm-hmm. So, we are maximizing some nutrient flows because there are, a number of organisms like microbes that are basically incorporating, flows into their bodies and building biomass, but it's not particularly diverse nutrient flow because honestly, everything's single-celled, whatever sexual reproduction didn't happen for, over 1 billion years into things. Like, it took a little while for some things to get going. Mm. But if you scoot forward in time, like, give life enough time, it will figure out how to diversify nutrient flows, and it'll figure out how to maximize those diverse nutrient flows in every ecosystem that's part of. Keystone species are really critical because they accelerate the maximization of diverse nutrient flows, right? Like, a beaver will go create a whole wetland, which increases the biodiversity in an area and creates lots of interesting habitat and lots of additional benefits. Anyway, long story short, then to get to the point of being able to be an economy and a civilization that maximizes diverse nutrient flows, it's almost like Epoch 2, but on supercharged, right? Instead of just understanding, hey, a hydrological cycle is an important metabolism, there's actually all these little micro metabolisms that are running in, a little cubic centimeter of soil. Mm-hmm. And if we could actually understand the metabolisms big and small, mm-hmm. the interrelations between those metabolisms big and small, and the organisms that help to create the most positive leverage on that, then you can basically start working with nature in the language of nature. And we can maximize the productivity and the wealth that nature creates and get to share in the co-created wealth of nature, as opposed to the extractive economy, which is the polar opposite of that. So it's going to take a while for us to get there because I don't think that we're even necessarily deeply interested, mm-hmm. As a civilization yet in understanding things at that depth. Now, if you sit down with anybody who like really studies something well, like an entomologist, and you go talk about ants, or you go and, you sit down with like, I don't know, somebody who specializes in wetland plants and talk with them about things, you will get a lot. You will start to hear the little signals of like, well, that's how the big metabolism works here. And then there's a little, sub-metabolism that happens more over the span of 10 feet. And then there's a little one down at the centimeter level. Oh, wow. And then there's a metabolism that takes 2,000 years. And then there's another metabolism that takes 15 minutes. And when you actually listen to these folks, you're getting all the clues. Mm-hmm. In the same way that like a business person will go, walk around a conference and hear different opportunities like, oh, you know how there's a vendor shortage on sunflower oil since the Ukraine invasion, which is true, because it's like 70% of the sunflowers were made in Ukraine, for global export. You'll hear these little clues that are giving you ideas for the business opportunities of the future. Then similarly, as we start to really understand these metabolics at all these different time and spatial scales, then we will start to have that as the foundation that creates the clues of the businesses that should be created. Because you're like, well, soil function is actually not just one thing, right? It's like, 600 metabolic loops like that. And then if we were to really focus on just the fungal, mycorrhizal to plant root metabolics, then man, let's talk about what we can do. And you could get into something pretty amazing like that. You could be remediating soil. You could reduce the amount of inputs required to go grow things. You could do a huge amount of economically productive things just by understanding that metabolic a little bit deeper than the kind of surface level.
Wow. Yeah. Tom, we've covered a lot of ground. I appreciate your time so much. Any final words or messages you want to share?
Oh, yeah. So if you want to go follow more of this work, you can go to my website, tomchi.com, tomchi.com, or the venture firm's website is @one ventures, ATONE ventures.com. And yeah, we'll be publishing out talks and stuff. Like, actually, maybe you guys can share the talk version of this when you publish it out. And I think it's like, what I would recommend to anybody is don't be in conceptual land, be in the work. Like a lot of the things I've talked about conceptually today are the culmination of doing a lot of the work in the field. And then like pulling out, okay, this worked, this didn't work. This worked, this didn't work. This worked, but only because of this nuance. And I think for the folks that care about this stuff, spend as much time with the people that are actually getting their boots dirty, literally or metaphorically, and start to understand the nuances of what it actually takes to do some of this repair, some of this industrial upgrading, some of the necessary disruption. Like, see what that looks like at the ground level, and then kind of stay in that activity pattern. Don't get hypnotized by the people that are saying like, there's just one big solution for it all. No, there's not actually. If you sit down with the metabolics and you actually play through all the things that need to industrially change, all the things that need to change with the relationship to nature, it's more like hundreds of things. And somebody's got to be the pro at every one of those hundreds of things. And I think if you spend some time in an area, if you spend a year and a half in an area, you probably catapult yourself up to the top 20% interesting people working in it. But yeah, because we're at that stage right now. It's actually still kind of ground floor for a lot of the hundreds of things that need to happen. So even a year and a half, 2 years of investment of just deep diving in one of the metabolics that needs to be repaired, you could become one of the top voices in it and make a big difference.
Tom Chi, thank you so much.
Thank you so much.
All right, that was quite the conversation. You can learn more at @oneventures.com. There's a link in the show notes. We're going to continue to explore these intersections of planetary health, finance, and exponential technologies. So stay tuned. You can subscribe to our channel on YouTube, as well as visit maearth.com. Thanks for tuning in, and I'll see you next time.